Welcome, ladies and gentlemen. Today we're going to be solving absolute value equations. So you're going to need your notes, a pen and or pencil, and a calculator, please. You need to make sure you write down your learning objective. Our objective today is that we will be able to solve an absolute value equation. Now, we've talked about this a bit before, but absolute value, so make sure you get everything on this page written down, please. Absolute value represents the distance from 0. So the absolute value of 3 equals 3 because 3 is 3 units away from 0. And the absolute value of negative 3 equals 3 because negative 3 is exactly 3 units away from 0. So now what we're going to do with this knowledge today is that we're going to learn how to solve an equation that contains an absolute value. So this is how we're going to start looking at this. If you could write down, this is example number 1. We're going to be graphing it. We're going to see how our graphing is connected to solving our problem. So if we look at our problem, absolute value of x plus 2 equals 5. If we think back, we know how to graph f of x equals the absolute value of x plus 2. So we graph this. What this means is that we're going to shift to the left 2. So I go left 2. My slope is just 1, so it's up 1 over 1. So I'm going to go off in both directions, up 1 over 1. So make sure you guys on this one, you get all of this stuff written down, please. The problem, the graph, all of it. So we know how to graph this. Once this is graphed, now what we're going to do is we're going to look at it and we want to know, when does this graph equal 5? So here's 5 right here. And we want to know when the graph equals 5. So the graph equals 5 right here. So that's going to be at negative 7. And the graph equals 5 right here. And that equals 3. So it's going to equal 5 at 2 different points on our graph. So our solutions are x equals negative 7 and x equals 3. Because that is where our absolute value graph intersects with 5. Okay. Now we could do this for every problem, but we're going to look at another way to make this work without having to graph each problem. We're just going to set it up and we're going to solve them. So I have 3 more examples that have to be written down in your notes. This is the first one. Here comes the next 3. So what we're going to do when we get an equation like this, absolute value of x minus 3 equals 4, we are going to set up 2 problems, one for the negative slope side and one for the positive slope side of the absolute value function. Because whenever we look at our graphs, one slope is positive and one is negative. So if we set this up, the positive one's going to look like this. It's just going to be x minus 3 equals 4. Now, the negative one, all we're going to do is we're going to put a negative sign out in front. Equals 4, representing that this is going to be our negative slope. Now we're going to solve both of these. If I solve this one, I'm going to add 3. So x equals 7. If I solve this one over here, I can distribute my negative if I would like. So I'm going to get negative x plus 3 equals 4. Solve this, I'm going to minus 3. Negative x equals 1. Divide by negative 1 on both sides. X equals negative 1. So here are my 2 solutions. Now before I can guarantee that they're solutions, I'm going to check both of them. So when you check, all we're going to do is take the original answer that we got and plug it into our original problem. So if I check this one, it's the absolute value of 7 minus 3 equals 4. Absolute value of 4 equals 4. We know the absolute value of 4 is just 4, so 4 equals 4. That one works. If we check this one over here, we're going to check negative 1, so we have absolute value of negative 1 minus 3 equals 4. So this is going to be the absolute value of negative 4 equals 4. We know the absolute value of negative 4 is just 4, so 4 equals 4. So 7 and negative 1 are our solutions. All right, moving on to example number 2. Here's example number 2, ladies and gentlemen. Now, before we can set up our 2 new problems, we have to get the absolute value by itself. We always have to do that first. So what we're going to do is we're going to subtract 5 on both sides, and I get the absolute value of 5x minus 10 equals 40. Now that's my original new problem. So I'm going to set up my 2 equations. My positive slope is 5x minus 10 equals 40. My negative one is going to be a negative, parenthesis 5x minus 10 equals 40. Solve both of these. This one I'm going to add 10 to both sides. I get 5x equals 50. Divide both sides by 5, x equals 10. Over here, instead of distributing this time, you can if you'd like to distribute, but you can also get rid of the negative right away by dividing by negative 1. So you're left with 5x minus 10 equals negative 40. Add 10 to this. 5x equals negative 30. Divide by 5. X equals negative 6. Now we have our 2 equations, now we need to check them. So if I check this one into, now I'm going to use this one. You can use it in the original, or you can use the one we already had the absolute value by itself. So when I check this, it's going to be absolute value of 5 times 10 minus 10 equals 40. So I have 50 minus 10 equals 40. Absolute value of 40 equals 40. So 40 does equal 40. This one does work in our favor. Now if we check this one, plug it in, we have the absolute value of 5 times negative 6 minus 10 equals 40. Absolute value of negative 30 minus 10 equals 40. Absolute value of negative 40 equals 40. So 40 does indeed equal 40. So our solutions are x equals negative 6 and x equals 10. All right, there's example number 3. The last example that you have to have in your notes is this one, ladies and gentlemen. We're going to set this up. If you look right here, it says check for extraneous solutions. Extraneous solutions mean like solutions that aren't going to work when we plug it back in and check. That's why we check all of our answers to make sure that we don't have any extraneous solutions. So on this one, you see our absolute values by itself, so we can go ahead and make our positive and negative equations. So I have 2x plus 12 equals 4x. And then I have negative 2x plus 12 equals 4x. So I'm going to go through and solve these. I'm going to subtract 2x on both sides. I'm going to get 12 equals 2x. Divide both sides by 2. 6 equals x. Here, over here, I'm going to divide both sides by negative 1. So I get 2x plus 12 equals negative 4x minus 2x. 12 equals negative 6x. Divide by negative 6. And negative 2 equals x. So these are my 2 solutions. Now what I need to do is go in and check into my original problem, okay? So if I check 6, it's going to be the absolute value of 2 times 6 plus 12 equals 4 times 6. We have to plug that x in 2 spots now. So I have 12 plus 12 equals 24. Absolute value of 24 equals 24. 24 equals 24. So 6 is a solution. Now if I come over here, I'm going to check negative 2. So when I check this one, I'm plugging it back in. So the absolute value of 2 times negative 2 plus 12 equals 4 times negative 2. Absolute value of negative 4 plus 12 equals negative 8. Absolute value of 8 equals negative 8. Well, 8 equals negative 8. This does not work. So this is not a solution. So the only solution that we have on this one, ladies and gentlemen, is x equals 6. X equals -2 does not work. Okay, so that's why we have to check our answers, because sometimes both of them will not work. All right, ladies and gentlemen, that is all I have for you today. I hope you go out and have a fabulous day, and I will be seeing you later. Bye.